Human beings have always been fascinated by the stars. For thousands of years we used our imagination to fill the sky with patterns that we call constellations. By finding pictures in the stars, we told each other stories about how the cosmos worked. We also learned to use the constellations to work out where we were, allowing us to navigate the seas and map the world. Today, astronomers know that star locations are random, the constellations no more than a useful illusion. But the stars still tell us where we are in the universe, and the more we find out, the smaller we seem. The closest star to Earth is our Sun. Like all stars, it's a ball of extremely hot gas that produces huge amounts of energy from nuclear reactions in its core. Even though it is more than 1 million times bigger than Earth, the Sun is a fairly average sort of star. Some of the largest would fill our solar system to beyond the orbit of Mars. Our Sun is 150 million kilometers away, so far that sunlight takes 8 minutes to travel to Earth, even though light is the fastest thing we know of in the universe. The next closest star to Earth is Proxima Centauri. Its light takes more than 4 years to reach us, and some of the most distant light we can see with a telescope comes from galaxies that lived and died before our planet Earth even existed. No star lives forever. Our own Sun has a lifespan of about 10 billion years, and we've probably reached the halfway point already. The less massive stars use up their fuel more slowly and last longest. A star is a balance of two powerful forces: the gravity generated by its tremendous mass, which pulls inwards, and the pressure of the radiation generated in its nuclear furnace, which pushes outwards. When a star begins to run out of fuel, its core shrinks and gets hotter, while the outer layers expand and cool. A star like our Sun eventually releases its outer layers gently into space, while its core shines on as a white dwarf star. More massive stars come to a more dramatic end, when the core collapses suddenly and the outer layers blast out into space in a supernova explosion. Out of the gases and dust expelled by dying stars, a cloud called a nebula may form. As more and more particles cluster together, the gravity created by their mass gets stronger and pulls in more matter. When the cloud eventually collapses under its own gravity, the nuclear fusion process begins again, and a new star is born. Since the time of the Big Bang, hydrogen and helium gases have been cooked together in the hearts of stars to form all the other elements in the periodic table. And the matter that stars release into the cosmos when they die is woven into the fabric of our extraordinary universe and everything in it, including our Earth. So the stars don't just tell us where we are, they also tell us what we are, because every substance on Earth, from the salt in the sea to the iron in your own blood, had its origins in the ashes of a dying star.